Okay, okay. Just got in from college, so hopefully. Very good, very good. That's good to hear. Start from the. Alrighty. Okay. Let's get to the big board, or at least the base cam. Alright, hello everybody, good morning slash afternoon. I hope everybody is doing absolutely fantastic to here today. Great to hear, great to see everybody today. Hopefully everybody's doing very well here today. So, right. Good stuff, everybody. Good stuff. Whew, we're back from the weekend. Gemma, hopefully getting from college wasn't so bad. Just cuddling is that. Oh, so cute. Josie, hello. Good morning slash afternoon. Hopefully you're doing absolutely fantastic here today. Hopefully we're doing well. Today is not a bad day. Today's a pretty good day, actually. I don't know what it is about today. I don't know what it is. Good vibes. Good vibes coming from today, from Monday. Mostly the time people's like, Monday is kind of boring. Like, yeah. You know what? I feel like good vibes. I feel like good progress will be made. So, Dram, what are we drinking today? Sadly, all I got is water here today. I need to get some fresh drinks, or I can bust out. Actually, I do have a few more drinks in the fridge, technically. Um, you know what? You know what? I'll let you choose, Josie. I'll let you choose. It's the evening. Yeah, I know it's the evening for you. Uh, I got the veggie juice. I got some of the body armor juice in there. Um, what else do I have? I don't have much. Those are the only two I got. Those are the only two I got. Bernice, good morning slash afternoon to you. Which one should I go with here, Josie? Because I got water sitting next to me, but I can easily swap that out. Um, it is the same peach mango. I just bought the two first, so I didn't really go shopping this weekend, so I don't go shopping that often to be honest. But I'll let you go ahead and choose for me anyway. I will. Yep. Okay. Then I'm gonna swap out the water for that. Give me just a second then. That's fair process. I always listen. Give me a second. Mango. Just as you requested. There we go. It's gonna be our drink for the day. Till I get some new ones, of course. But we'll go with that. Some peach mango body armor. All right, left over. Get some possibly new flavors there. All right, very good, very good. Oler is doing fantastic here today, and we have a lot to talk about here today. That's for sure. some of it's like, but I think we'll be just fine. How was everybody's weekend? Everybody's weekend went well. Hopefully it did. Hopefully all of you had a wonderfully nice time. Hey, Danny, hello, good morning slash afternoon. Hopefully you're doing absolutely fantastic, Danny. Look at this, we got a lot of great people out on the stream here already today. Ready to go. We're in really good shape, let me tell you. Oh man. Look at all these people. They're all coming out here for the stream to watch little old me teach mathematics. I'm so shocked. It's almost like I forced you to know. I'm just kidding. I will never force people. I'll never force people. It's not how I do. How I do. Whew. All right. That eye dust is eye dust. All right. Whew. All right. We're almost set to go here. We got about 4 minutes to go. Hopefully, again, I don't know what you guys did for the weekend, but I know what I did. It's like I was a little busy making up a few things regarding the tests and whatnot, and just come from the daily catch-ups. Fair. My friend got me back. My friend got me back into playing a game. So I took a 5-year hiatus from playing this game, and looks like I'm back to playing the game again. Jess, hello. Good morning / afternoon. Hopefully you're doing fantastic. Absolutely fantastic. There's a couple things I'm gonna need to do. I know after class. They won't take me. Actually, one thing will take me. I'll explain it. Everybody doing great? Hopefully everybody's doing great. Yes, yes, yes. Absolutely great here today. I'm digging today. Digging today, digging the vibes. Ooh, some good stuff there. Alright. Woo! How we doing today, Jess? Hopefully you're doing good. Hopefully you had a wonderful weekend here. Hopefully you're ready for some mathematics. I know I am. Lot to discuss, lot to go over. But I promise you, things will start to be a lot more clear here starting from today. I got the rules for the exam. I got all that stuff kind of starting squared away. Be starting off talking about a few things, talking about that. And then yeah, that's the plan, and then we'll do a couple sections and we'll get right to it. That is the plan here. So just a couple more minutes here and then we'll go ahead and get going here. Here we go. Just a little sunburned. Oh, I see. Spending a lot of time outside just walking around. It's nice weather out there. It's like 90 degrees though. It was hecka hot. I ain't gonna lie. I know what happens if I go out in the sun, you know. I basically, if I go out in the sun, it's like, okay, you go from already I'm, toasty tan by just genetics, it just turns darker. So, basically my skin goes from like a 3 on a toaster scale to like a 5. It gets, a dark toast. That's just how it works, Swimming weather. Hey, swimming and me. All I have to do is sit back, relax, and float on the water. Lobster red. Hey, Nicholas. Hey, hello. Good morning / afternoon. Hope you had a good weekend. I had a great weekend. There's a few things I probably should have done this weekend, I'll admit. But those are things I can easily make up. There's one thing I definitely have to do after class. There. Lobster red. Yeah, I'm the toasty brown kind of guy. Like my skin will literally get just dark. I look. The nice part about having my skin color, I'll admit, is that I save at least $10 because of the fact that I never have to go to a tanning salon in my life. Everybody wants to be my skin color. That's just how it is. They go to the tanning booth. That's what my mom told me. Like the doctors, when I was born, they basically threw her like a $10 coupon, to go to a tanning salon. It's like, hey, congratulations, you saved yourself a little bit of money. Like, great, good job. Yes. Like, people want to be like me, be the same color. That's why you go to them tanning beds, let me tell you. I just get to keep it permanently. for the rest of my life. That ain't so bad. uh, I ain't gonna lie, it's a nice feeling when you have a little bit of a little bit of a little bit of an advantage. Oh my gosh. All right. Okay, ladies and gentlemen. All right, let's do some intros here. Let's go ahead and get started. And yeah, we got a few things of which to talk about. Okay, let's do some intros. Okay, ladies and gentlemen, and we'll go ahead and get going. All right, let's do this. Okay, that works. All right. Okay, let's get started today. Welcome back to Monday. Hope you had a nice weekend. All right, so for today, ladies and gentlemen, we are going to first and foremost here. We're going to a few things on our agenda. First of all, talking about the test here. That's something that I wanted to discuss here. Um, first and foremost. Secondly, we'll talk about just a small update that I kind of forgot to do this weekend, but I'll quickly do it after class. And then thirdly, we're going to get into two more sections here, which you see on screen, which are sections 2.5 and 2.6. As we didn't got done with 2.4 here last time, we'll do those two sections. We'll wrap those up here. Last section of chapter 2, by the way, will be section 2.7, which will be getting done tomorrow. We'll quickly transition, by the way, tomorrow from the end of chapter 2 and we'll go right into chapter 3. But test number 1 here that we'll discuss here first and foremost, we'll be covering chapters 1 and 2. Again, chapter 1 is just basically sections 1.1 and 1.5, and then chapter 2 will be 2.1 to 2.7. Okay, well, to kind of start to understand exactly how things are going to go in terms of tests. All right, so I have made up a preliminary amount of tests here. So I'm going to answer a few questions that people had from last week. And I want to acknowledge those and want to acknowledge at least the rules that I had in mind and exactly how things are going to go. Um, yeah, I'm going to be answering that right now, Stephen. So about when the chapter 1 and 2 tests. So the first test there is chapter 1 and 2 combined together because chapter 1's only 1.1 and 1.5. So let me go ahead and acknowledge that here. So I'm going to go to the main screen here for just a moment. And I want to show off here about what I have planned for you. Okay, so this is what's going on here. Now this is the settings here for this exam. Okay, so this is the settings here for this exam, and there's going to be a kind of a lot of behind the scenes thing that I'm going to be perfectly transparent about. Okay, about how things are going to go. This is still a work in progress on one front, but that is something that I'll be taking care of after class here today, this afternoon. Now, this test here has not been posted, all right, not for you, right, because it's still a kind of a work in progress, but things that are set in stone are things that you can see here on the screen, but I want to go over it one by one. That way everybody knows exactly what the story is. All right, first and foremost here, let's talk about the due date here. All right. So this is going to be my plan. All right. And this is going to be entirely up to you. Now, what I was thinking about is that usually what I do in a class like this is I usually give a week's worth of warning before I do an exam. And that would normally be in a 16-week class. All right. Now, obviously, we're an 8-week class because we meet for the entirety of the summer. And we do have 5 exams here in class. Meaning, if I gave you a week's worth of warning here, would it be possible to fit 5 exams and a final in there? Uh, probably not. I'd probably just be making an announcement literally every week, and literally every week you'd be doing a test. So again, one of these things about this course here, at least the way I conduct it, is it's always been about kind of self-pace. It's always been kind of one of those sort of deals, at least for me anyway. And so what I've decided to do is I'm going to make every test here due the same day as the final exam. You're going to have to pace out when you want to do these tests here. Okay, but I made that due the very final day of class. Again, one of the things that I don't suggest that you do is try and do all these tests at once, as it will probably be an abject disaster. So That's pretty bad here. That's not something that you want to do necessarily. So I'm gonna have this test here due on the very last day of class here, which is the 29th of July at 11:59. Now, let's talk about a couple things in relation to some settings here. First and foremost, you do get partial credit on multiple part questions. That's perfectly fine. I do limit the amount of attempts you get for a test, which is 5. Okay, you get 5 attempts per test. Again, the best score is the one that's recorded on your grade book, and that's the one that I go ahead and take into account. And that's pretty easy. You get a really good job on your, on the test, and that's the score that counts. Be pretty simple and straightforward. All right. Um, in order to make sure that pacing can be done appropriately here, I have the save for later option. So, save for later option says you can leave and return to the test to complete the test. When you return to the test, you cannot access questions that you answered in earlier sessions. So, for example, let's say you want to get a few questions done in one day, and you're like, okay, I get like, 5, 10 questions done. You kind of shut down for the night. You come back and get the last, 10, 15, 20 questions done in another day. Yeah, you could go ahead and do that here. Again, though, any questions that you already did try and you did save, those you will not be able to go back. So once you take a guess, that's it. You can't go back to that question again. Okay, so once you have that done, it's done, and then that's it. All right, so that's how the save for later option is going to go. There'll be a little bit of a button on the upper right hand corner which will say save, and then you can log off once you've saved on that particular problem. Again, be sure that you save on a problem that you already have guessed on and not the following subsequent problem that you did not, and otherwise you can't go back to that one either. Okay, I do put a test limit here. Again, that'll be 600 minutes, so literally 10 hours. Okay, literally that should not take you too long to do. 10 hours is pretty straightforward. All right. Um, I don't think that'll be too much of a problem, at least in terms of getting that thing done. So 10 hours, pretty straightforward. All right. Okay, and so that is going to be that here at least for the settings here for pretty much every exam. So I'm gonna have that set up here for pretty much every exam, and we'll see exactly how things will work out. Are there any questions here so far, by the way? Please let me know if you guys have any questions before we move forward. Yes, 10 hours. That's correct. So 600 minutes here. Yes, that's correct. So the time will stop if you do like a save for later option. All the tests are in my math lab. Yes. Um, Okay, that's a wonderful question, Nicholas. Good question. Okay, let me go ahead and acknowledge that question right now. All right, so first of all, first half of your question here, are all tests going to be on my math lab? The answer is yes, absolutely. That's absolutely true. Every test, the final exam, definitely on my math lab. But we have a video going as we take the test. Uh, I'm a little confused by that question. What do you mean by we'll have a video going? Are you talking about like having like a camera directed to you? Like basically like having a video camera directed to you? Is that if that's the question there, Jess? I'm just a little confused. Um, while you get back to me on that here, let me acknowledge here Nicholas's latter half of the question here. Um, oh, proctored basically. Oh, the whole lockdown thing. Yeah. Not really, no. I mean, like I said, you could take your own time with it and stuff. The only thing that you won't have access to is resources that you could get online. So I basically took away all the learning aids and stuff. So, what do you mean by 5 attempts? I mean that you could try the test 5 times, and the best attempt that you get on the test is your score that will be recorded. So you get 5 tries on the test. So literally, you can retake the test like 4 more times if you don't like your first initial score, Bernice. So that's basically what that's referring to there. You have to turn in our work for the exams, like take a picture. No, no blink. You don't have to. Now, all right. Let me just point this out here because there's the second half here. And will Nicholas's second half of the question here, will they look similar to the homework? So, for full disclosure here, I'm going to switch here to the content here regarding this exam. Now, the content here regarding to this exam is not finalized yet. So, don't be scared here of what you see here on the screen. This is still preliminary. All right. Now, what I've effectively done here, for full disclosure, is I've basically taken every question from chapters 1 and 2 here, like in this particular instance. I go ahead and put it in to the pool of problems here that are possible for the exam. So this is like my pre-work that I like to do. Now, there are 125 questions here from what I gathered from the homework here. Now, of course, you're not going to have 125 questions for the exam. So let's not freak out here. Okay. I'm going to pare this down very, very carefully here. I'm going to certainly get it down to a much more manageable amount. A manageable amount to me would be like, somewhere 30, 40-ish type of range here. So will everything necessarily be on the exam? I mean, I try to keep it as comprehensive as possible, but the answer is no. So that's kind of a me issue where I'm going to have to pare down like 75, 80-ish type of questions, maybe a little more, um, in order to get it down to a proper exam length. So um, that is something that I'll have to do on my end. But this is how I basically select all the questions for the exam. Is basically they're exactly the questions that you see there from the homework. Okay, so there's no difference on about how I'm going to be what you're going to see on your homework. Okay, so if you try out the homework, that's going to be kind of your way to kind of see exactly how what kind of questions to see. And again, the test here is going to directly reflect that in some kind of fashion. All right, so again, full disclosure, full transparency, this is exactly how I am intending to do any and all tests here for this class. All right. Now, to go along with this and what is not set up just yet is once I figure out what problems I'm going to go ahead and put on the test here. Once I go ahead and figure that out, and that's kind of the second half, what you're going to see here is you're going to see at least 2 things posted. You'll see a practice test, which will have all the learning aids attached. All right, so you can practice the same exact test as the real test. All right, so it'll say like chapter 1 and 2 practice test. You can try the same test here just with practice stuff, and you can see how you do with the practice test. Again, it'll have all the learning aids attached to it. And then when you're ready to take the real test, you're ready to take a real attempt, you can go ahead and do the real test there. And then you won't have the learning aids attached like the help me solve this and stuff. But at least if you do the practice test, it'll give you pretty much blow for blow what the real test will be like and what questions you're going to see. Obviously, the numbers are going to be different, but you're going to have a very good idea about what to expect when you do the actual real test. So again, I'll be having a practice test and I'll be having the real test there. So recommendation for you is to go ahead and do the practice test here first. And if you try the practice test here and you do pretty well with that practice test, then maybe a few bonus points heading your way. If I feel that, I'm thinking maybe some bonus points heading your way. So way you can grab a few more points if you try out the practice test here. And the practice test hasn't been posted yet. I'll probably be posting that after class here today or by tomorrow for sure. But that is what the story will be in regards to the 5 in-class tests here. So I just wanted to be super duper extra sure here, okay, about how the tests will be conducted and exactly what we're going to be doing here for the exams in class. There's a couple things I kind of was debating about the due dates here for the exams. And I'm like, well, that's kind of a lot. It's 5 exams. I'm like, yeah, it's gonna be constantly on, is it like I felt like the exams would be just constantly on your ass, the whole 2 months. I'm like, yeah, just kind of through it. Have it do at the end of the semester so you could just take it at your own pace. Just a lot easier that way, and it's such a short time frame that we're having to work. So, um, I felt that was a little bit more appropriate in that regard. Um, okay, so that's what I wanted to tell you here regarding the exams. Um, are there any questions, any other questions you may have in regards to how the exams will be done? Yeah, it is like, yeah, Nicholas. There's a lot of information out, and again, it's for full transparency's sake. So, you it'd be 2-1 to 2-7. Uh, Ryan, no problem, dude. Okay. Just a quick note here. One thing I kind of forgot to do this weekend was to upload the replays here up to YouTube. I'll be making up a playlist here after class, and I'll be making up a playlist after class. I'll be uploading all the replays there up to YouTube. Um, and so you should see some stuff here on uh, just to see some stuff there on that. If you ever did help with the practice test, you can ask. Yes, yes, you can, Jess. Not a problem. Tia, just to confirm, the tests are due when? The tests are due the final day of class, as is every test here. Be due on the final day of class on July 29th. So again, it'll be due all tests including the final, which I haven't obviously made up yet. So the very final day of class. Again, you have the whole time of which to do it. Do I recommend you take the whole time which to do it? No, I don't. But again, for full disclosure, that's uh that's how we're going to take it. So again, since everything is on a short time frame, we need to I need to be realistic about that. So any other questions? Yeah, that's one thing I will recommend is not to get too complacent or lazy. You can take a day off here or there, but again, with a 2 month time frame to kind of get everything done, it's a little bit compact nonetheless. So I ain't gonna lie. Make sure you don't fall behind in terms of giving yourself enough time to get the homework and the tests done. No questions? Okay. All right. So that is that. Okay. So again, I'll be posting this up here. I'll be making some more announcements here about when these are posted and whatnot. Again, right now they're not posted, so you won't have access to them just yet. But once I go ahead and edit this test down here and whatnot, I will go ahead and make the announcement that it has been posted, or you'll see it for yourself when you try some homework stuff. You go to tests or whatnot, and then you'll see that here. If you go to if you're on the main menu here, you'll see quizzes and tests, for example. If you click on quizzes and test, you're going to go ahead and see the tests listed here. You can ignore all this junk, but there'll be a test like chapter 1 and 2 test and whatnot, so you'll see that for sure. Okay, all right. Okay, okay. So let's move on here into the actual material here for today. Um, so got all that stuff squared away. So let's move on to the actual material today. We're going to move on here into section 2.5. All right. So section 2.5, we talked about, last time we talked about slope and y-intercept and, some important points regarding that, how to find the equation between 2 points, parallel, perpendicular. We talked about that here from last time. And we're going to kind of switch gears here for just a second. We're gonna talk more about functions, of course, but today we're going to talk about transformation rules of a function. So we're going to take a look here about how to do transformation rules regarding a function here, at least knowing, what happens to a graph if we take a function, we add, subtract, multiply, divide, do all those sort of things. And what happens to the graph in that case? All right, let's take a good look here. A lot of these here are going to use pretty much the same example. So you'll see exactly how this works out. All right, so let's take a look at number 1 here. It says, what are the transformation rules of a function? All right, so what are transformation rules of a function? So here we have a list of possible transformation rules, and we're going to go through each one here. So it says f of x plus c. Again, c is a constant number. It could be the number 5. It could be whatever you want. But let's go over a simple example here. Let's see what happens to the graph when we go ahead and say add c here to the outside. Now, what exactly does that mean? Let's take a function here in this case, and we're going to take one of the simplest functions to use, but one of the best functions to definitely use here when it comes to actually graphing to see what kind of patterns and behaviors that we have here. So first and foremost here, let's use our function here, f of x equals the absolute value of x. Okay, so let's use that first and foremost. This is a nice little basic graph here, the absolute value of x. Why is the absolute value of x really easy? Well, because absolute value makes everything positive. Plug in a number, and then basically apply absolute value, it becomes positive, and everybody's a winner. So let's plug in some numbers here, let's see what we get here. So here we get 0, and you plug in 0, absolute value of 0 is still 0, that's fine. Absolute value of 1 is still 1. That doesn't change. Absolute value of minus 1 is 1, right? That doesn't change. You could do, minus 2 is 2, 2 is 2. You get the general idea. All right, so nothing too fancy going on here, at least in terms of the graph, right? It is what it is. Let's just put it on a simple graph here, see what we're working with. You're like, kind of boring? I'm like, yeah, I totally get that. It's kind of boring. Minus 2. We got 2 comma 2. All right, and so if you've seen an absolute value graph here, it kind of looks like a big letter V. Okay, so not V for vendetta, but V for victory, as you got it. All right, good stuff. So here is the basic graph here for the absolute value of x. All right, so everybody sees that here. Everybody possibly have seen that at least once. No problemo, easy peasy lemon squeeze. All right. Now what we're going to do here is taking this basic graph here, all right, we're going to use this as a comparison marker here. And we're going to look at other variations of the absolute value of x starting from this very first guy you see here. So let's go with this. Um, let's go with this. Let's go with the absolute value of x plus 2. Okay, so let's go with the absolute value of x plus 2. All right, so let's do a small little xy chart here. If we plug in 0, we get 2. Okay. If we plug in 1, we get 3. That's perfectly fine. If we plug in minus 1, what do we get? What happens if we plug in minus 1? What do we get for our value for y? If I plug in minus 1, what do we get for y? Okay. So we get 3 there. All right, perfect. All right. So again, apply that. No problem. Easy peasy. Got 3. All right. Now these 3 points are pretty sufficient for what we want here anyway. You could try 2 and minus 2. That's perfectly fine. You'll find those to be 4. All right. In any case, let's take a look at the graph here. We have 1 comma 3 here. Okay. So let's compare this graph to what our original graph is. So what's the difference between the original graph of absolute value of x and the absolute value of x plus 2? What's that difference there? Move the up 2, right? Yeah, right? So we took the original graph, right? It's like if we took, let's say one thing that's nice about the absolute value graph, it's super easy to kind of visualize. Like if you took the ends of the graph and you kind of moved it up by 2 units, that's essentially what you effectively have done, right? Exactly. You've shifted it up vertically by 2 units. So what we're going to do here is we're going to define each of these transformation rules. This will be vertically a vertical shift. If I can spell. Um, a vertical shift up by C unit. Okay, so you vertically shift up by C units. There you go. Easy enough. All right. So that's the first one there. All right. What do you guys think will happen with minus C? What will happen with minus C? What if I was subtracting by 2? What would happen if you're subtracting 2 on the outside? Right? So it just makes sense, right? It's a downshift, right? Exactly, right? So we could just conclude by simple logic that we'll have a vertical shift down by C units. All right? All right, so no problem there. Simple enough to see. You guys can see that. Again, it would just go down by C units. Fine. Seems fair. All right, let's do that. All right, cool. All right, now let's look at another example here. Trying to make. All right, let's do through the next one here. All right, so the next one here is going to be, say, f of x here is equal to, now let's go with this first one here. It says x plus c. Now what exactly does that mean here? That means that that constant here is on the inside here. So let's say this is x plus 2, but this time here the plus 2 is inside the absolute value. Okay, so the inside here we have the absolute value. There we go. All right, so let's plug in some numbers here. 0, we still get 2 here. All right, so 1 here, we get 3. That part is still true. So just like the last guy here. What do we get for minus 1? What do we get for minus 1 here? Minus 1, we get 3? Oh, look again. Well, I asked the question here. You're going to take it for granted. Yeah, don't take it for granted, guys. That's why we never assume in this class. Got to do it out. So meaning to say, hey, if you're trying to do minus 1, so if you're trying to do minus 1 here, it's got to be careful with that stuff. Again, -1 is on the inside here, right? It's on the inside of the absolute value, right? So you have to do what's inside the absolute value because you treat it like parentheses. You get the absolute value of 1, which is 1. Yeah. I know. But that's why I have to ask the question here because everybody's kind of like, "Oh, it's the same thing, man," and I'm like, "Oh man, it's not the same thing, bro." It's like you wish it was the same thing like every single time, but you got to take it case by case. That's why one of the things that I learned in mathematics, in all honesty, Nicholas and Josie, is like, hey, I never assume anything. I just go ahead and I just kind of take a look at it on case by case basis. Sorry if I missed it, but why are we using absolute values? That's just the function that I just decided to use there, Blink. So again, that's the Absolute value, at least for at least teaching this concept here, is one of the best ones to use here to visually see what the transformations actually are. Um, let's try another one though. I like absolute value because it's super predictable in that regard. Um, let's try -2. If I plugged in -2, what do we get? We get here for -2. All right, a boatload of nothing. Sounds good to me. How about -3? About -3. What do we get for -3? -3. -3, we get 1. All right, so be a little careful there, Joseph. All right, so remember how this works, okay? So really quick here for absolute value, at least the property for absolute value. You plug in -3 in for x, right? So agreed that you get -1 here, but again, you have to apply the absolute value last. So you first figure out -3 plus 2 there, and then apply the absolute value, and then that's where you get 1 from. Okay, so be a little bit careful about that. At least for absolute value, that's how it's going to work. Okay, so you'll apply that guy here after everything is said and done on the inside. All right, so let's go ahead and put together a graph here. We got 5 pretty good solid points. So let's take a look at the graph. All right. All right, so here we get 0, 0, 2. Okay, so fine. Here it is. We get 1, 3. So, 3. There it is. We get -1, 1. So there we go. There it is. We get -2, 0. Oh, 0, 2. I'm a dum dum. That's 2, 0. All right. Say I'm like that. Here we go. And we get -2, 0. We get -3, 1. All right. So what does this graph kind of look like here? Again, this graph is going to look like a V here, just like so. Okay. There we go. All right. So this is our graph here. All right. So based on what we see here compared to the original graph, the OG graph here of absolute value, see here on the screen, what's the difference between both of those graphs? But what happens in this case? Which way does the graph shift? Shift it to the left, right? All right. All right. Good, good, good. Okay, so again, I just want you to physically see here. You say, hey, the top graph there in red is absolute value of x. I said, now the bottom graph there is the new one after we added 2 on the inside. I said, yeah, it shifted to the left, and again by in this case 2 units. So this a horizontal shift left by c units. All right. Now you could probably guess what will happen for the other one here. If we subtract by c, what happens in that case? So if we have the absolute value of x -2, -2 on the inside there, what would happen with the subtraction? Okay, so by process of elimination, right? And some simple logic, you'd be like, okay, it's just the opposite. The horizontal shift right by c units. Okay, so again, keeping this in mind here, pretty much we have the first 4 kind of knocked out here, so it shouldn't be too bad once you go ahead and see what the difference is. Easy enough. All right. Any questions so far? Any questions so far? Hopefully everybody sees that portion there. I believe someone asked, but are these always absolute values? I'm not sure about what you mean by that question. Are you talking about? Again, I'm using absolute value graphs to notice what the transformation rules are there, Ryan. But I'm not sure what you mean by that question. If I'm getting it wrong, this is for this can apply to several different types of graphs, by the way. So, but I'm using absolute value as a backdrop, so that's what I'm using it for. If I'm misunderstanding you, please just go ahead and clarify for me. Hopefully, and I'll understand. Oh, okay. Okay, so one thing about absolute value is it's going to be in the shape of a V. All right, so it's actually a sharp V here. A parabola is slightly different than what an absolute value is. Absolute value is a sharp V, and it's going to look like this. All right, parabola here is rounded. Okay, so there's a distinct difference between the two. And that's because the property of absolute value is different than that of a quadratic function. So two different ways to draw the graph there, if that's the question. So we're just fleshing out generic rules here, again, but we can apply it to generic graphs as well, which we'll be looking at in the second question. Yeah, so don't mistake like absolute value and parabola. They're two different things. Man, Lachlan, I haven't heard that before. I had a colleague named Lachlan. Nice dude. Too bad that Lachlan was not a nice dude. Thank you for the band. Um, you got there before I did. That was pretty fast. Any other questions before I move forward? Any other questions? Move on to the next one here in just a second, but I want to make sure everybody's pretty clear about what we're doing here. Absolute value will always look like a letter V of some variety. Yes. Actually, let's look at the next one here. I'll show you where things can be slightly a bit different. Pointy V shapes of some variety, yes. Tis true, tis true. Let's showcase the next one here. Why not? Let's showcase the next one. All right, so the next one here is, as you see there on the list, we have negative f of x. So what exactly would that reflect? That's basically if we had this. So let's go with the next one here. We had f of x here. Let's say this happened to be negative absolute value of x. So the negative here is on the outside, right? So this says minus f of x. It says, okay, the negative is on the outside. All right, seems fair. So here we're just going to go ahead and do the xy chart here. Now 0 here, we definitely get 0. All right, so 0 doesn't really do anything. Now let's answer this question here because this is actually rather important for this guy. If I plug in minus 1 into this particular function, what would I get back out for y? If I plug in minus 1, what do I get back out for y? Okay, so in this case here, what we're going to get here is we're actually going to get minus 1, okay? Hey, Chaz, how you doing, my friend? How you doing, my dude? See ya. That's right. So the negative here is applied after the fact we take the absolute value. So here's how it will work. So if we plug in -1 here, the first thing that we're going to do is we're going to have negative the absolute value of -1. Good, my bro. Very good. Very good. What you been up to, my dear? So here we're going to take the absolute value of -1 here. That's going to be 1. So you apply the absolute value to what's inside here, and then you tack on the negative after that. So that's why we get -1 here as a result. Again, just do the order of operations in this case is plug in the x, then take the absolute value because we're done with that on the inside, and then apply the negative at the end. So that's why we get -1 here as a result. Yeah, I want to explain that to you, Brian. Be like, because it seemed a little confused. Like, why did we get 1? Like, why is that magically -1 instead? Okay, we want to be able to see how that actually fleshes out. Again, for the same reason here, 1 will work out the same way. That'll be -1 as a result here. I kind of had a feeling. I kind of, I kind of had a feeling that's exactly what you were thinking. That's that's what exactly what I was worried about. That's why I need to bring you on board here, buddy. I'm like, oh crap. It's like, what kind of hellscape have you what kind of hellscape have you drawn me into with this sorcery of yours? I promise you it is not as bad as it may seem. Just on the surface. Just on the surface, there's shenanigans. Algebra doesn't stick. Oh, well, this is horrible. I'm so sorry. I didn't mean to make this the 7th level of absolute hell, okay? I promise you. It's supposed to be slightly a bit better. Yeah, no problem, no problem. All right, all right, these 3 points should be sufficient enough. You could try for 2 and -2, you get -2 and all that stuff. All right, anyway. Let's put it on the graph here. We got 0, 0 here. We got 1 comma -1. We got -1 comma -1. All right, so here we are going to get a V-shaped graph here. All right. Wow, that looked absolutely horrible. My drawing skills are second to none, as in second to nobody really cares about drawing skills. As in they're non-existent. All right. Anyway, so this is the graph that we get here. Kind of this upside down V here. So what is so here's the original graph of absolute value of x. I'm just kind of pointing that out up top. And here is our graph here with the negative on the outside. What happened to the graph there? We compare the original to the now negative absolute value of x. What happens in that case? Okay, it flipped upside down. Okay, that's fine. It flips. All right, now the question is, all right, so here's the question. Okay, so there's a second question to this, ironically enough. So if it flips, right, what axis does it flip over? Does it flip over the x-axis or does it flip over the y-axis? Hmm. All right, so remember that the x-axis is here and the y-axis is here. All right, flip or translated? Well, the translation is the flip itself there, Jess. So the answer is we take this graph here. So imagine this is our OG graph. So put the OG graph here on the side here. The OG graph is a V that looks like this, okay? So we take this guy, right? Take this guy, and we flip it just like so. Like we flip it, we reflect it like so. The formal way is just say reflect. But again, take it, we're taking it by both hands, and then we're bringing it down here across the x-axis. So the answer to this is in formal terms. I remember the vocabulary. That's okay. That's why we're going over this carefully. Reflect or flip, whichever way you want to call it. A flip. Um, about the x-axis. Okay, so that is what we have here for negative f of x. That is how that's going to work. So that's why we went from a V here shaped like this, and now we take that, we flip it over, and now you get an upside down V that looks like what we see here on the screen. Okay. All right. Now, what do you think will happen for this? What will happen if we have f of negative x with the negative x on the inside? Now, again, what would that look like here for the absolute value? I'm not going to really draw this out here for a couple reasons, but here if we had, say, f of x here was the absolute value of minus x, so the minus x here is on the inside of those absolute values. What would happen in that case? What would happen here? So if I know that basically first one here is reflected or flipped about the x-axis, what would be what would happen if the negative is on the inside suddenly? What do you guys think? What would happen in that instant? What would happen in that instance? That's the key question here. Wouldn't shift horizontally, no. This isn't the difference between vertical and horizontal. Okay, yeah, the opposite here of x would be, what's the opposite of x here? We have the opposite of vertical would be horizontal, right? Well, I mean, the opposite of like up is down, the opposite of left is right, okay? But the opposite of x here would be y. That's right. So again, in this case here, it would be the same exact thing. It'd be reflect or flip about the y-axis. Now, the reason why I'm not putting this graph down is because at least unfortunately for absolute value in this case, absolute value of negative x here, like it's written on the screen, would actually result in the same exact graph that you started with for the absolute value of x. So unfortunately for us, it doesn't really actually change the graph any, because flipping over the y-axis, you actually would get the same exact graph. But there are other graphs that certainly would be more reflective of flipping about the y-axis. Unfortunately, this is like the one case where absolute value doesn't do very well, is showing that one off necessarily. But you just basically taking the graph, you're flipping it over the y-axis, and essentially that's what you get at the end of the day. All right, let's go ahead and take a look here at some of the other guys here, the next four per se. All right, so I want to take a look at that, and we'll see exactly how that works out. We're going to look at the what I'm going to do is I'm going to bust out the calculator for these next guys here using absolute value as our backdrop once again. Okay, and we'll compare the graph here to the original. So I'm going to scroll up here to the original actually first. I'll go to all right. So everybody can reference here. I want you to reference this graph here. All right, I'm going to move this over to the right because I would like you to take a gander here. Actually, I may end up just putting this on the all right, let me go ahead and put this on the graph here. So the first graph that I'm going to put here on the calculator is absolute value. Now, if you're not sure how to get absolute value, you can follow along with me, or you can just watch me do this. But absolute value here is if you hit the math key here, you can go to NUM, which is number one here, ABS stands for absolute value. So if you click on that, ABS stands for absolute value. So if you're not sure where you can find absolute value, that's where you can certainly find it in that cases. Math, go to the NUM submenu, and then number 1, which is the absolute value. So again, math key, NUM submenu. Uh, all right, so that's how I went ahead and did that. All right, so here's what I'm going to do for this next one here. In this case, you're going to have a constant here on the outside. So let's say I pick 2 here. Actually, no, let's pick 3 this time, just to kind of highlight that. And then we'll pick the absolute value of x here. All right, there we go. So 3 times the absolute value of x. Fair enough. All right, let's see what happens here when we graph these two together on the same guy. All right, so the blue line here is the original OG graph, and the red line here is the new graph of 3 times the absolute value of x. Okay, so now comparing those two here, what's the difference between the original graph, the blue one, and the new graph, which is the red one? What's the difference that you see there in this case? What do you guys think? What's the just tell me what a difference is, and we're gonna then take a look here. Red is more acute. What does that mean? If I looked at it from a vertical, red is pretty narrow, right? I agree, it's acute. That's true. So it looks like it's more narrow, right? It looks like it's more kind of scrunched together. Like we took both ends of the graph and we kind of pushed them together, right? I would say that that's pretty accurate. I would say that's what the acute essentially is. Okay. Now, because this looks more, quote unquote acute or things like that, in this case here, with 3, we multiply 3 times the absolute value of x to get this particular graph to work out. Let's take a good look here at the actual behavior of the graph here. Now, in this case here, there are 2 behaviors going on. We're going to look at it from a vertical perspective and from a horizontal perspective. Now, from the vertical perspective here, again, the way the book kind of states it isn't that great, which is why I want to kind of go over both. Hey, Firsty, how you doing, buddy? College stuff is going great. We're doing good. Doing some transformations of graphs if you like to follow along. All right, so here, in this case here, what we have is we basically vertically stretch the graph. So we vertically stretch it, meaning to say, vertical stretching essentially means is that we take both ends of, like in this case, both ends of the absolute value graph, and we stretch it out just up like this. Okay, so you take both ends, you grab them from the handles, and you stretch it out like this. That's essentially what you're doing. So it'll be a vertical stretch, but we're going to take a look here, and you can basically take both ends of the graph, and you see there that it's also horizontally you're shrinking. Okay, so you vertically stretch up because it goes up faster, but you horizontally shrink because again the horizontal side here has been narrowed. So it's a horizontal shrink. So from the x value standpoint, you're much more narrow. From the vertical stretch, you're much more again you pull it up just like this. Hey James, how you doing? Yes indeed. You get a thumbs up from me. Absolutely. James, how you doing today, buddy? Hopefully you had a wonderful weekend there. Hope you had a wonderful time. Hopefully you and Rach are doing absolutely fantastic. So, y'all good? Good. I'm doing absolutely fantastic, James. 100%. Talking about graph transformations here. I know. Super fun, let me tell you. You'll like this part here. All right. So I want you to notice one thing. Hay fever. Ooh, no fun. I've had hay fever before. That's a bad feeling. That's a bad feeling. Admittingly, Tokyo has some nasty hay fever because you get hit from 3 directions. Ever live in Tokyo, hay fever is brutal, even in an urban jungle like that. You get from 3 directions there. Posture check, absolutely, Bernice. Got that. Let me hear that. Thank you very much. Okay. Now I want you to notice what we just did here. Here we had C is bigger than 1. All right, meaning to say I put in 3 times the absolute value of X. Now what happens if I change that number here? So let's say I changed that number. Let's say I didn't have 3. Let's say instead I had a number between 0 and 1. Let's explore and see what happens in this case. So what would happen if I put in, say, 1/3? What would happen if I had a number here between 0 and 1, and I put in 1/3 times the absolute value of X? What happens to our graph then? Let's take a gander. All right, so the blue graph is our OG graph. The red graph here is our new graph here with 1/3 times the absolute value of X. Now, can anybody tell me here what happened in this case? What happened to the vertical side and what happened to the horizontal side? Do we vertically stretch or do we vertically shrink? What happens in that case? Do we horizontally stretch or do we horizontally shrink? Anybody tell me what happens in that case? Take a look at that. What do we do? What do we do there? Shrink vertically. 100% correct, right? Because now it's much more flat. It's like taking both ends of the graph and you kind of, it's like, like imagine if you had 2 iron bars and a V and you just kind of pulled them apart like this, right? If I pretended I was really strong, which I know that's not, humanly possible. My upper body strength is a non-existent entity. But if I could, okay, realistically, if I could, all right, if I could, I'd bring it out and I would have a vertical shrink because again, it looks like super duper flat from a vertical perspective. Okay, so in this case here, it is a vertical shrink. How about horizontal? How about horizontally? Would that horizontally be the stretching or would it be shrinking? What do you guys think? Mean my non-existent upper body strength. It's true though. Horizontal stretch, that's correct. Right? Because it's much more wider, right? 100%. I pulled those 2 bars apart and I'm now stretching out horizontally, okay? So you can actually physically see me do it. This is the only time you'll ever see me exercise on camera, but you get the idea. Okay? You're stretching apart here. All right? That's You're like, that's kind of sad. I'm like, yeah, thanks, guys. So that's what'll happen there. That's true. All right, seems fair. All right, good. All right, now let's take a good look here at one more particular example. Let's see what happens here. Now that you guys have a pretty good idea, let's see what happens here if we change the position of where the number is located. So let's say inside the absolute value, we put the number in. So let's start off with the absolute value of 3x. Let's say what happens in that case, right? Let's take a look at the graph there. You take a look at the graph there, and if it's, let's say the value of the constant here is bigger than 1, well then you still get the same properties here. You vertically stretch and you horizontal shrink. Okay, and if you did the same thing here for the next guy, James, what did you do for the weekend, by the way? I have to know. Hopefully you got a chance to get out and do a little bit more if you were working for hashtag this weekend. Sure, things are starting to ramp up since this season's going to start pretty soon. So, okay. So here, let's put 1/3 x here. Take a look at the graph here. And if you see here for 1/3 x, even if I put it on the inside here, we get the same kind of result here. So here we get again. Get a vertical shrink. Horizontal stretch. Okay, good stuff. All right, and that's how we can go ahead and know what the transformation rules are for functions. Any questions so far? Any questions so far? Hopefully everybody's on the up and up here. Like James stepped up. All right. Okay. All right. I'm a little confused how the last one is different from the second to last one. Uh, you're talking about how the difference between 3 and 1/3 is going to be? Again, notice that this is the same thing as this in terms of its behavior. So even if the constant here is on the outside or it's on the inside, they're both, oh, there's no difference in that regard. No, the property is exactly the same. Whatever reason the book put it as using a horizontal and vertical, but I didn't like it that way. I wanted to show you that the property here is exactly the same, even if the number's on the inside compared to it being on the outside. So I did want to kind of provide it that way because the book kind of shows it like, oh look, this one's vertically shrinking, and then it does it on the inside. It's like, oh look, this is horizontally stretching. And I'm like, well, wait a second, it's the same exact thing. I said you should probably say that. So the book doesn't do the greatest of jobs in regards to that. So I wanted to show that the third to the last and the last one here definitely are the same in terms of its behavior, regardless of wherever C is located. So I wanted to be sure that that was pretty clear, so that wasn't it doesn't make it like super confusing. Technically, I could put horizontal stretch and vertically shrink, but what am I doing? I'm just reshuffling the deck chairs. So I'm like, not a difference here, you know. So yeah, I'm just trying to put it out there. Any other questions before I move forward? Any other questions? Okay, so let's go over question 2 here. All right, so question 2 says, what are some basic function graphs? All right, so that's what we're going to do here for question 2. What are some basic function graphs? All right, so there are many basic function graphs that easily can be applicable here for any and all of these transformation rules. All right, so what are some of those basic ones here? Well, the first one that we can clearly see is f being the absolute value of x. I think you've all seen that already many a time. So I think that's the first one here. We'll go ahead and just state is just that. There's the graph right there. Again, we're now just going to look at basic graphs here. I'm not going to do too much here. Just something that's pretty straightforward. All right. Okay, let's look at some other graphs though, because we've seen a lot of absolute value of x here. Yo, X, how you doing, my dude? Hopefully you're doing well. Going over some basic graphs, my friend. Thank you, thank you. Um, let's see if you can get this one. All right, this one here is x, okay? So absolute value of x, pretty straightforward here. Again, the most basic of basic graphs here. Plug in a number, you get that same number right back out. Easy peasy lemon squeezy. As we all know about x, it's just a line, okay? Nothing too fancy going on here. All right, so if you put that together, it's a line. You go la 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 la. It goes like this. There you go. Easy peasy lemon squeezy. Hey, Gomesh. I'm doing well. How are you? hopefully things are good. All right. Okay. Let's look at another one here. All right. So a lot of these graphs here you've seen before many a time. Just going to quickly go through these. So next one is x squared being the pretty easy quadratic. Plugging in some numbers here, we get 0, 0. We get 1, comma 1. Hey, thanks X for the follow. Appreciate that. All right, if we plug in -1, we get 1 here. Again, 2, we get 4. -2, we get 4. All right. All right, so here we get 0, 0. Get 1, comma 1. Again, -1, comma 1. 2, comma 4. You guys know what this looks like here. It's going to be our regular old parabola dude. All right, so nothing too fancy going on here. All right, so there's absolute value. There's the, not absolute value. There's the x squared here. No problemo. All right, so that's another basic graph here. Again, why am I doing these basic graphs? You're probably wondering why I'm doing these basic graphs here. So the reason why I'm doing these basic graphs specifically is because of the fact that you want to know in your mind where you're starting from, and then you can describe the transformations about, what you're shifting up, down, left, right, whatever the case may be. Okay. So if you understand where you're starting from here and how you're shifting up, how many units up, down, left, right from your starting point, then it becomes pretty easy. So having the basic graphs here can be certainly very helpful. All right, next one here is the absolute, is not the absolute value, is the square root of x. Square root of x here, again, make a simple xy chart here. XY chart here for square root 0, 0, we get 0, 0, 1, we get 1. We get 4, we get 2, you get the square root of 4, which is 2. Square root of 9, which is 3. If you want to continue adding more, that's fine. You'll just put in the first 3 there. Again, we cannot take the square root of negative numbers, but we can for the first positive 1, 1. And 4, comma 2, just like so. What's this graph look like here? The graph is going to look something akin to this. There we go. Another basic graph bites the dust. 100%. All right. Now, last set of graphs here are graphs that are used sometimes. So again, I will certainly acknowledge these guys, and we'll take a look at that. So first one here, like I said, used sparingly in examples here. Will you see graphs like this? I'm like, yeah, technically that's true, but x to the third, definitely one of those that are used from time to time here in examples in the book. Is it used often? The answer is no, but again, the basic graph here. I know I'm kind of paraphrasing a lot here, so going rather quick, but again, this graph here, not a crazy graph here. It's like, okay, it is what it is. So if you do it out here again, hey K-Pink, how you doing? So if you do it out here, you go like this. It goes up. It kind of flattens out. Kind of goes up like this. There you go. That's x to the third from a basic standpoint. Easy enough. Alrighty. And then finally, this one here, again, not used super often, but again, some occasionally, very occasionally. That's the cube root of x. Okay, so if you take the cube root of x, that's going to be slightly a bit different here. Cube root has a very different behavior to it. Again, you can put 0 there, you get 0, you get 1, you get 1. You can even plug in -1. -1 for a cube root is perfectly acceptable. That is actually -1, and that includes the other guys here. At 8, you get 2, and minus 8, you get minus 2. This is actually acceptable terms for a cube root. Again, cube root does not work the same way as a square root. All right, so that is why you can put in negative values and be okay with that. So we get 1 comma 1 here. That's all nice and good. Negative 1 comma negative 1. You take a look at the graph here of this. This kind of goes up like this, and it kind of goes flattens out like this. This one kind of flattens out this way. So this is basically the graph here for the cube root of x. Again, another basic graph here, should you want to take that into account. There you go. Dunzo. All right. Okay, so we have all of those there. No problemo. All right. Are there any questions about this here? Any questions? Any questions at all about transformations here? Hopefully, with these basic guys, it is going to be pretty straightforward here about how we're going to be tackling those type of problems. So, yeah. Good shape. No? Okay. Okay. So, if I had this, let's do one quick example here, and then I got to move forward to the next section. So, if I had this here, let's say I had let's describe the transformations if I had this as an example. All right, so if I had negative the square root of x minus 2 plus 3, what would be the transformations that would apply here in this case? So can you guys describe to me the transformations? We're not going to look at the graph. We're not going to do the graph here necessarily, but just describe to me the transformations. So i.e., how many units it shifts up or down, left or right, okay, based on the rules that we have here in the notes. So what would it be here if we had this here? Right 3. And be a little careful here. Again, that 3 is on the outside there, Brian. So again, with this 3 on the outside here, that's what we're going to be talking about shifting up or down. If it's on the inside, you're going to go left and right. So we got up 3. That part is true. We're going to shift right 2. Right. Okay, so the minus 2 here is on the inside, so we go right 2 because we have a subtraction there on the inside. Right? That's just shifted right by units. And that's okay, man. That's not a problem. But that's why I asked the question. You just make sure that we cover our bases here. And reflect about the x-axis. Okay, that's correct. Reflect the x-axis. Good. All right, that's correct. There you go. So we would start with our original graph here, which is our OG graph here would be square root of x. So our OG graph here is the square root of x. Then we would, again, take that graph, we would shift it up by 3, we would move it right by 2, and then we would flip it about the x-axis, and then that's the graph that we would get. Again, in your mind, that will get you a very good physical representation in your mind of your expectation of what the graph will look like. Okay, and if you did it on your calculator here, all right, so now I'll do it on the calculator here. I have this, and then I go ahead and clear this out. Go ahead and do this, and we have all right, so then if we look at the graph here, you see the expectation that we have here. There you go. You see now what will happen if we reflect it. All right, easy peasy. All right. Good stuff. All right, now, so instead of memorizing these rules, you can plug into the calculator and you're good. Well, if you can memorize what happened before and after, you can. There's the only problem with the calculator is this. Calculator is decent, but again, it doesn't tell you exactly what those rules are now, do they? So what you're trying to do is you're trying to go to the well to try and do something that the calculator can't do, which is necessarily tell you what kind of rules are being applied in those instances. So what you're trying to say is you're trying to interpret basically what the calculator is telling you, but you're not sure. And so you're going to spend more time actually doing that stuff, entering in stuff in the calculator over and over again, rather than just memorizing the rules and then making it faster for yourself. So I always say, like, okay, it's okay to rely on technology and stuff, but sometimes just memorizing stuff is much faster than just having an over reliance on technology necessarily all the time. So there is merit to memorizing things so that way you don't have to like constantly check yourself every 3 seconds all the time. So I'm like, I don't discourage it, but I'm saying, you know, sometimes it's the lazy way out. No problem. What I type in the calculator? Yeah, I just went to the y equals. Oh, not there. Um, I went to y equals and I just put in uh square root of x and then the actual function negative square root of x minus 2 and then the plus 3 on the outside. Then I just hit graph after that, Stephen. And that's where I got these two graphs from. So, I mean, you can look at the graph on the calculator. I just don't be like, yeah, it's fine. It's just like, again, I don't want to make. I want to be sure that you just when you start critically thinking, it's all about can you put those pieces together yourself? And you're probably saying, well, why is that important? Necessarily, it's thing is that you want to be able to one of the things that I learned is that you critically think it's kind of like the starting that I start of kind of putting those things together in your head, making your own decisions and whatnot. I always liken it to be like being more aware about what's around you when you critically think rather than having something as a crutch always fall back on. So doesn't apply to everything, mind you. There's good times you can use a crutch. So I'm not saying it's not saying that's bad all the time. Trust me. Uh, yeah, you can't put a subtract. You have to use the negative key on your calculator, Stephen. Yeah, the calculator is very specific about that, Stephen. You have to use the negative key. Minus sign does not work when you put the minus sign on the outside. Calculator is very specific about that. It'll basically throw you a context error for that. So be sure you put the yeah, it absolutely does not like minus sign out there. It wants a negative key out there. Okay. All right, so that is the end of section 2.5. Any other questions before I move forward? Can you explain how I got that answer? Are you talking about like the shifting it up and down and whatnot? Yeah, if you got a homework question, yeah, feel free to either email me or we can contact via Discord and I can help you out with that link. So again, the plus 3 on the outside here. So let's look at our rules here. We have a plus 3 here on the outside. Okay? We have a plus 3 on the outside. So because we have a plus 3 on the outside, we know that's a vertically shift up by that many units. So that's the first one here. We are going up by 3. Next, we have a minus 2 here on the inside. Minus 2 would reflect a horizontal shift to the right by C units. So hence why we have it shifting to the right by 2. Then we have a negative here on the outside. So we'll have this negative here on the outside. This negative here on the outside of the function reflects or flips about the x-axis. So I'm just using these rules on the basic here, EMAT. That's why I'm just writing it down and be like, okay, just going one at a time. What do each of these pieces represent? Like, okay, let's look at the rules and see what each piece represents. And then there you go. That's how you know the process of how to determine the behavior of the graph. Easy enough. Oh, thank you, Blake, for the hydrate. All right. Okay. We got to move forward here. Let's go ahead and move forward. Yes, stomach. All right. Next one here. Let's look at the next one. All right. So I don't know. We'll get through all of section 2.6, but we'll get through most of it here. Some of it actually, just not all of it. Yeah. Probably get through these first couple questions here. Then probably for next time we'll finish it off with section 2.7 as well. All right. 2.6. What are sum, difference, product, and quotient of functions? Okay, now this is actually pretty straightforward. So in this case here, you have f plus g, f minus g, f times g, and f over g of x. Again, they actually equal their respective counterparts. Exactly probably what you're thinking here. If you have f plus g of x, you're just adding the functions together. If you have f minus g of x, you're just subtracting the functions from each other. Multiplying is multiplying, and division is just straight up division. All right, so there's nothing fancy going on here, at least in terms of how we approach this here. The notation here is exactly as it sounds. I do promise you that. It's really not as bad as it may seem. So let's go ahead and separate this out again. Actually put this on the left side. Okay. Okay. So let's go ahead and put down two functions here. Let's say f of x here is let's say with my classic 3x minus 2. And g of x here is going to be, let's say 2x squared minus 3x plus 1. Okay, so let's just go with that. All right, so how do we go ahead and do each one here? Well, pretty simple stuff. Let's say you have f plus g of x. Again, that's f of x plus g of x. All right, so we're just separately taking these two guys here, and we're just throwing it in, and then adding up our like terms and doing the like. So nothing too crazy going on here. It's pretty much exactly what it sounds like. All right, so here we get, again, 2x squared. What do we get here? 3x minus 3x, so that's 0. Minus 2 minus 1, so minus 2 plus 1, pardon me. We get 2x squared minus 1. All right, fine. Seems fair. There you go. That's f plus g. Let's take a look here at f minus g. So using our base definition here we get f of x minus g of x. Okay, now I do want to point out one thing here regarding f minus g, and that is, in this case here, I put the note here, remember to distribute the negative in g of x for f minus g of x. Again, take a look here. Remember, anything we substitute, we always put parentheses around. Once again, this is going to prove to be very, very important. All right, so at least when you plug it in by itself, it's not so hard. But remember, because we put in parentheses around everything we substitute, we need to distribute the minus sign here to everything in g of x. So we need to change these signs here respectively. All right, so that, don't forget, that's the most common mistake I see on these particular guys is like, okay, well, you gotta subtract here first, and then you can go ahead You got to apply that negative here first, and then you can go ahead and add up your like terms all you like after that. So I'm going to go ahead and apply, okay, that in this case, and then we'll go ahead and see what we get here. So we get minus 2x squared, 3x plus 3x is 6x, and then minus 2 minus 1 minus 3. All right, so that's f minus g. Just making sure that we take that into account. Simple enough, very straightforward, easy peasy lemon squeeze. All right. All right, next one here is multiplication. So here we have f times g of x. All right, so we're not doing anything super fancy here. We have f of x times g of x. All right, so here we have 3x minus 2, and we have 2x squared minus 3x plus 1. We'll just multiply and FOIL those out together. We're going to get our answer. That easy. Let's go ahead and FOIL this out here first. We get 3x times 2x squared is going to be 6x to the third. 3x times minus 3x is minus 9x squared. 3x times 1 is 3x. Right, and we have the minus 2 here. Contribute to all three of those. We get minus 2 to minus 4x squared plus 6x minus 2. Okay, let's see what we got here. So we have 6x to the third. We have minus 9x squared minus 4x squared, so that's minus 13x squared. 3x plus 6x, that's plus 9x. And then we have a minus 2 here. And there we go. We have f times g. Easy peasy, lemon squeeze. All right. All right, and then finally we have f over g of x, which is probably the most straightforward one, because sometimes you apply it and sometimes you don't. So, and what I mean by that is like sometimes you can do something with it, I guess, and sometimes you can't, just because of how it could factor or something. But typically the way we approach this is nothing too great. So again, we put in 3x minus 2, that would be up top, and on the bottom here, be 2x squared minus 3x plus 1. Again, if you can factor out both the numerator and denominator and something can cancel out, then go ahead and do it. Otherwise, there you go. That's your final answer. There's not much you can do with that, really. I think you can factor the denominator there. I just made it up. Um, but actually you can't. But if you can factor it and something cancels, then go ahead and try. Otherwise, leave it alone, and that's all you got to do. If you have to evaluate it, evaluate them is pretty simple. It's pretty easy. You can go ahead and just plug in numbers there. You can just multiply, add, subtract, multiply, divide. They're very straightforward. All right. Questions about number one. Really is just kind of some busy work there, but nothing too crazy going on there in that instance. I find that to be pretty straightforward. So really nothing too much happening with that problem. No questions? Okay. Good stuff. All right. So far, so bueno. All right. Okay, so let's take a look here at the second part um, of this guy. Now, today is kind of like a lot of information here, so I do apologize. Um, Sometimes some days are going to be like that, but important nonetheless. All right, let's take a good look here at the next question. Number 2. How do we write a composition function And what is it equal to? Okay, so I wrote down the definition here. It says it's a function composed by a function inside another function. Take a look at that in a second. Therefore, the domain inside the function is part of the domain of the outside function. We'll expand on that here in a subsequent question here. But let's talk about the notation here. The notation here is actually really important. All right, so the notation here is basically defined as FOG of x. Okay, so this is one way you can write the notation here for a composition of functions. Now, in this instance here, the notation is incredibly important because order does matter. Okay, so without question here, and we'll put that as a note here down here. Well, that note order matters. You notice that FOG of x is equal to f of g of x, where you have g of x is on the inside and the f is on the outside. But GOF of x is not the same. It says f of x is on the inside and g is on the outside. So hence, order does matter here. It means that if we took a look at this composition sort of deal from a general perspective, we don't get necessarily the same thing here from the first one to the second one. And heck, even the third one, we can compose a function within itself. We have FOF of x, we have f of x. Okay, you can actually do that there. Now, what exactly does that mean here? Let's take our same two functions here that we have from before. Okay, so let's write down our same two functions here. Let's apply them one more time. Okay, this time though, let's compose them together and see what we get, right? I think, that's a little bit more important. So all right, so let's write down our two functions here again. F of x will be 3x minus 2, and g of x will be 2x squared minus 3x plus 1. Okay, so those are our two guys here. Let's see what we get here when we compose them together. So let's start off with FOG of x. So FOG of x is going to be f of g of x. Now, if we play a simple substitution game here, which we're prone to do, we're going to take this g of x, right? And we're going to take that definition of g of x, put it on the inside here. So what we're going to have here is we're going to have f of 2x squared minus 3x plus 1. That's the definition here of g of x. That's the straight up definition of g of x. No problem. Okay? Now, remember what we did here when we first evaluated functions. Anything we plug in, we're just going to play substitution. That's all I'm doing. We're going to play substitution here. So whatever this is, I don't care what this is. This could be anything really. I'm just going to plug that in for every x, in this case, in f of x. I'm going to plop it in just right in there, just like so. And now we can go ahead and figure it out. We get the minus 2 here. Forgot about that. So here we get 6x squared minus 9x plus 3 minus 2. Adding up our like terms here, we get 6x squared minus 9x plus 1. And that's our final answer here for FOG of x. All right. Any questions about that so far? Any questions about how I found that? I want to be sure that everybody understands where we got that from. I promise you it did not come from out of nowhere. Not like a Randy or an RKO. I promise you that. Somebody gets it. All right, so here we got the first one here. No questions for that. Let's go ahead and take a look here at GOF of x. All right, so as I'm going to state here, GOF of x is not the same as FOG of x. But let's take a look about and see if that happens to be the case here for this guy. All right. Oh, all right, so GOF of x here is a G and then of f of x. Again, it's going to be G of 3x minus 2. Okay. Can anybody tell me here, what would this look like here? What would G of 3x minus 2 look like before we put it all together? What would we do here with G of 3x minus 2? What does that look like here? Type that out in the chat. G of 3x minus 2. What do you think that would look like here before we put it all together? I'm just going to plug in 3x minus 2 here, but what would that work look like? What do you guys think? Have 2 times 3x minus 2 quantity squared minus 3 times 3x minus 2 plus 1. Okay. All right. Stephen and Lysidena got that right. Excellent. Excellent. All right. Those are both correct. All right. So here, again, if it helps you, go ahead and, underline here. Very nice, Nicholas. That's correct. So again, if it helps you, underline it and know where you're plugging it in into that subsequent question, subsequent function here. So here we're plugging in 3x minus 2 in for every x in g of x. So we're just plugging it in to this guy, and we're plugging it in to this guy. That's where we're plugging it in. And exactly correct here, we plug in this. Here we got minus 3 times 3x minus 2. And then the plus 1. There we go. Good stuff. So far, so good. All right. Now, if we do this out here, actually, really quick, see if you guys, see if we that in the chat there. There we go. It's 3x minus 2 quantity squared. What is that going to be, by the way? 3x minus 2 quantity squared. What's that? Just 3x minus 2 quantity squared. Not x squared minus 6x. Okay, minus 6x plus 4. Good, good, good. So then putting it together would be 9x squared minus 12x plus 4. All right. All right. Very good. Very good. Don't forget those middle terms. You're going to FOIL that out. What they said. If you're going to FOIL it out, then that's what you got to do there. So remember, if you're having a tough time with this, okay, remember just write it out and FOIL it. So 3x minus 2 and 3x minus 2. And just FOIL it. Okay? So this is one of the things, again, writing this out here makes it significantly easier so you can see you're not forgetting those middle terms there. You're technically doing this 2 times, right? So again, hence that's why you get 9x squared minus 12x plus 4. And then you could proceed to do the rest of the problem here without too much trouble. All right. So then netting this out here shouldn't net us too much of a problem here. So maybe I just hit the maximum. Okay, whatever. Anyway, let's go ahead and do this out here. So we got 18x squared minus 24x plus 8 minus 9x plus 6 plus 1. Again, the plus 6 comes from minus 3 times minus 2, by the way. And if we do this out here, we're going to get a final answer of 18x squared. Let's see here, minus 24x minus 9x, so that's minus 33x. And then we get 8 plus 6 plus 1, so that's 15. All right. And there we go. We have our final result just like so. So notice here, they are not the same function, definitely not. So going FOG is not the same as GOF. All right. We'll put a second note here. FOG is not the same. Okay. I want to state that here because I don't want you to take it for granted it works the same as multiplication. The answer is definitely not. It is very different than that of multiplication. It is its own unique operator. Okay? Its own unique operator. All right. Now, one last thing here before yeah, we definitely won't get to that last part there, but we can answer number 3 here. How do we evaluate composition functions? Evaluating composition functions is pretty simple. So we'll take these same two guys here. Kind of running out of space, so I'm just if you want to evaluating them is actually fairly easy. Actually, surprisingly enough, evaluations with numbers here are pretty straightforward. So if I went ahead and I said, okay, can you tell me what, we'll use these same two functions here, 3x minus 2 and 2x squared minus 3x plus 1. If I said, okay, can you tell me what FOG of 2 is? So basically, all you have to do if you're trying to evaluate composition functions is you take f of g of 2. You first define it here. Okay, so you have f of g of 2. And so you want to go ahead and find out what g of 2 here is first, because you need to place that in those big set of parentheses here. We find out what g of 2 is here is first. And according to this here, it'll be 2 times 2 squared minus 3 times 2 plus 1. So here we have 2 squared, which is 4 times 2, which is 8. We get 8 minus 6 plus 1. So here we get, is that 2 plus 1, 3. So this 3 here that we see is going to be placed in for g of 2 here. So what we're going to have here is specifically is we're going to have f of 3. That's what we want to figure out. Because now we know that g of 2 is equal to 3. So here, we're going to have f of 3. Figure out what that is. F of 3 is, again, just plugging in 3. We get 3 times 3 minus 2. We get 9 minus 2, which is 7. Right, and that's how we can evaluate composition functions. Again, just take it one step at a time. do what's inside the inside function here first, all right, and then plug that subsequent number into the outside function, and then you'll get your answer for that problem. It's just that easy. So always 2 steps here to do the composition functions here. You guys want me to do another example, or are you guys good with that? All right, I'll do one more example then. Okay, let's do another example. That's fine. No problem doing that. Let's say we have a little bit slower too. No problem. Let's say we have FOF of -3. Or actually, let's pick GOF. I think FOF will be a little too easy. All right, so based on the definition here of GOF of -3, we're going to pick G of F of -3. All right, so let's answer this question here. What do we solve for first here in this particular problem? What should we do first? That's the big question here. All right, F of -3. So do what's on the inside here first. This F of -3. Because whatever that is, we're going to substitute in there where we've underlined. Now, basically, you're going to use F of -3 here. So that's 3x minus 2 in this case. So again, 3 times -3 minus 2. In this case here, we get -9 minus 2, which is -11. So now, oh, plaster check. Thank you, Blink. Appreciate you. All right. So now, what we want to do here specifically, again, is take this -11 here. I'm going to plug it into this place right here where F of -3 is equal to. So what we have next is we need to figure out what G of -11 is going to be. Because we went ahead and just plugged it in to where F of -3 is -11. That's what we got the first go around. Okay, before we move forward here, are there any questions about that? Does everybody understand where we're putting -11? Why? Okay, no problem. All right. Now we plug in -11 into our function for G. So 2x squared minus 3x plus 1, will be 2 times -11 squared minus 3 times -11 plus 1. Okay. So we have 2 times 121 plus 33 plus 1. So our result here, just care of this. So our result here in this case is going to be, let's take a gander. I'll quickly do this. That's 242 plus 33 plus 1. So that's 275, 76. All right. All right, so pretty straightforward there for 276. And we got our final result. That would be GOF of -3. Okay. Any questions about anything from today? I'm going to still need to do a little bit of work behind the scenes, by the way, so, but that's a me issue, not a you. So I'll be posting the test here either later today or I'll be posting the test here tomorrow. I have to actually go through it and nitpick it. So obviously I'm not going to give you a 125 question test. That's outrageous. So I need to lessen some work, definitely. All right. Very good. Very good. All right. Now, you guys know exactly where to find me. Either you can email me or I'm on Discord, of course. So if you'd like to contact me on there, that's perfectly fine as well. But we are out of time here for today, so we're going to pick up here from question 4, which is the last question from this section here from 2.6. We're going to go ahead and finish 2.7 as well here for next time. And we'll see if we could get to chapter 3, maybe, maybe not, just depends. But in any case here, all right, in any case here, let's go to the main screen here. Let's go to the big head screen thing guy. All right, there we go. Big head screen guy thing, yeah, all right. But I want to thank everybody here for coming on out here to the stream here today. I know today was a lot of talking, a lot of information dump. I really apologize about that. We just need to kind of knock a lot of that stuff out of the park here first and foremost. But hopefully went okay for most of you here, despite the information dump here. I want to thank you for your patience here today. I want to thank you all for coming out here to the stream once again. All right, I love you all of you. Absolutely fantastic job here today. Thank you so much, everybody. All right, I wish you all a very wonderful day. All right, thank you very much, Joseph. I hope you have a wonderful day as well. And as always, everybody, as always, stay safe, stay healthy, but most importantly, stay sane. Have yourself a wonderful day, everybody. If you'd like to talk further, I'll be on Discord here. Or again, feel free to email me for any questions as well. All right? All right, have a great one, everybody. We will see you tomorrow. Same time, same place, everybody. Right here on Twitch. Take care, everybody. We will see you then. All right. See you later, everybody. Have a great one. All right. Take care. Bye!